Alrighty, hi everyone. Next we're going to be doing an example of finding a confidence interval for our population mean. So here in our example, a hospital wants to estimate the average systolic blood pressure of the population mean of its adult patients. For the past studies, they know that the population standard deviation of the systolic blood pressure is 15 millimeters of mercury, and a random sample of 50 subjects are taken with the sample mean systolic blood pressure to be at around 130 millimeters of mercury for those patients. Here they want us to find a 95% confidence interval for the population mean and give its interpretation as well. So the first step that we're going to do here is calculate out our our critical value of z sub 0.95, where our confidence level here is 0.95. Okay, so here I want you to pause the video and try to find this on your own, because this is going to be the very similar process to how we did our previous example. And come back to the video so that you can see the answer. Okay, let's get started with how to find this answer. So the first thing you want to do when you're doing anything related to the standard curve is create a graph, or to draw it out. So we're going to draw out this value, standard curve, with our mean of 0. Remember that our mean is 0 here because we're working with the standard curve. And they're going to be somewhat close to the ends of our tails in our drawing. And just for completeness, I'm going to write the critical values out there. The area that I'm highlighting in yellow is our confidence level C, which we know as 0.95. That means that our tails are going to be equivalent to 0.05, because that is going to be the complement of our confidence interval. Because we have two of them, and we're only going to be considering one side, because our area of the standard curve is based off of the area to the left of a boundary. We're going to divide this area that we found by 2, because we will not be considering our right tail area. This gives us a value of 0.025 for our area underneath the left tail, underneath the left boundary. My apologies. So we go into our chart and we try to find the value that is closest to 0.025, which we actually have directly. That's this value here. Okay, so we're going to highlight and find where those two areas, where the column and the row cross. Yes, that's right. Okay. And we see that our critical value, our negative critical value, is negative 1.96, which means that the positive critical value is going to be reported as the magnitude of it, or the positive counterpart of 1.96. Okay. The next thing they want us to do is to find the margin of error. Okay. Because if we recall, when we're finding the confidence interval, we need to determine what the margin of error is going to be. Okay. So here our margin of error is defined as our critical value multiplied by the square root of our standard deviation divided by square root of n. So we actually don't have a square root here. We have a parentheses because we're going to be multiplying. Okay. We know that our population standard deviation is 15 because that was given to us in the original problem. 15 millimeters of mercury. Okay. We also need our sample size and our z critical value. So our sample size was also given to us at 50. Participants. And they also wanted us to find it at a 0.95 confidence interval. Let me do a different color there, actually. Let's do orange. And that was actually a part of our first step. So our z critical value is whatever the value is with 95% of the data already accounted for. And that's the number that we found above at 1.96. Okay, so we have all of our values here. And now we're going to plug everything into our equation. So the margin of error is equivalent to the critical value of 1.96, and that's multiplied by our population standard deviation divided by the square root of our sample mean, which are 15 and 50 respectively. Okay, I'm going to do whatever's in the parentheses first. So we take the square root of 50 and divide 15 by it. And we get something that looks like 2.12. Multiply those two values together, and we are left with a margin of error of 4.158. I'm going to go to the thousandths here. You should be okay with the nearest hundredths. Follow whatever the question asks you for your homework. And that is our margin of error. Finally, we're going to find our confidence interval. If we look on our formula sheet here, the confidence interval is given as our sample mean plus or minus the z critical value with our standard deviation multiplied by the square root of n, which we already did because that's going to be the same as x bar, or our sample mean plus or minus our margin of error. These are equivalent equations. Okay. So here we know that our sample mean is 130. Let me find a good color for this. Not the best color, but it's different. We'll do brown. That's also not highlighted. There we go. So what we're going to do is subtract our margin of error as well as add our margin of error to the sample mean. That's 130 minus the 4.158 that we found, as well as 130 plus 4.158 that we found. This will give us a value of 134.158 for the added part. And for our lower boundary of our confidence interval, we're going to have 130 minus 4.158, which I'm going to use a calculator for, 125.842. Okay, so you'll oftentimes see a confidence interval written in the form of like a coordinate, and that is how we have it written out here. This is how you'll see it on your homework as well. Okay, that's our confidence interval, but we're not done yet. They also wanted us to give our interpretation, and the interpretation is always going to be in a similar format like this. We are blank percent confident that our population mean for whatever your variable is, here we're looking at systolic blood pressure, and the population mean, is within the interval of blank to blank. So here, the percent confident is going to be based off of our confidence level, which here we have as 95. Make sure that this is a 95 and not a 0.95 because we're using our percentage. So we are 95% confident that the population mean for our systolic blood pressure population mean is within the interval of, state your interval. So here it's going to be 125.842 to 134.158. And that is your full interpretation for this problem. Okay. Next, we'll be going on to different problems where we're going to actually find out what sample size we should use to estimate a population mean effectively.